Use an appropriate procedure to determine the coordinates of the vertex of the graph of each of the following functions. Okay. Well, the easiest way to find a vertex is when you have a function that looks like this. A x minus h squared plus k, or if you'd rather, x minus p squared plus q, whatever. As long as it's in this form, this number is the x-coordinate of your vertex, this number is the y-coordinate of your vertex. And that's exactly what they've given us here, so the vertex here is just waiting for us to grab it. It's minus 5, comma, 8. The horizontal coordinate is always backwards, sign-wise. The vertical coordinate is always correct, so here the appropriate procedure for this one is just to read it because they've given it to us in the ideal form. The 2 has nothing to do with where the vertex is. It just tells us that this curve opens up, so it's U-shaped rather than upside down U-shaped. B is going to be a bit more work because it's not in a useful form. It's in trinomial form, and so completing the square is how we manipulate it to make it look more like these guys. So, completing the square, we need to take a 2 out of the first couple of terms. 12 divided by negative 2 makes negative 6x. Leave some space, and there's our minus 13. Now, you're used to this step by now. Take the middle coefficient, cut it in half, that's negative 3. Square it, that makes 9. So we get a plus 9 there. And then to cancel it out, because this is negative 2 times 9, we have to put on a negative 2 times negative 9, because those are opposites. That way we haven't changed the equation overall. This is factorable, and it factors as x minus 3 all squared. And then we have minus 13, and then we have minus 2 times minus 9 is plus 18. So, when this thing is all straightened out, it's x minus 3 all squared. Minus 13 plus 18 is plus 5. So where's our vertex? These two numbers tell you. The vertex for this curve is at 3, 5. Oh, and I noticed they say state the maximum or minimum value of each function, so there's a little more required of us here. This first curve had its vertex at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. Vertex is there, and because this is positive, that means the curve opens up. So, this is a minimum value here. It's the bottom of a valley, and the minimum value is 8. This curve has a minimum value of 8. For B, our vertex is at 1, 2, 3, 1, 2, 3, 4, 5. And the fact that A is negative tells us this parabola opens down. If it opens down, then this is not the bottom of a valley, it's the top of a hill. It's a maximum. And the maximum value from our vertex coordinate is 5. So if they open up, then they have a minimum. If they open down, they have a maximum. And the value you get from the y-coordinate of your vertex. Here it was 8, here it was 5.